Hello there. This little video will be dealing with this thing called the side angle side triangle area formula, SAS, triangle area formula, and I'm going to show you the proof and a couple of examples on how to use it. Okay, so let's get started. Here's our first idea right here. Here's your basic triangle. A couple of sides labeled, the angle in between those two sides is labeled, and you know already the area of that triangle is 1/2 the base times the height. That's just how we figure out the area of a triangle. Our formula that we're going to look at today, though, does not use the height of the triangle. So we're going to show you a very simple little way around using the height of the triangle. So watch this. Here's the triangle again, and instead of saying, here, I'll write this equation down too, which I hope you can verify to be true. The sine of angle C is the opposite over hypotenuse, right? So that would be h over a. And with just a slight little algebraic manipulation of that equation, I can solve it for h and get a sine C. So a times the sine of C equals the height of the triangle. Okay, so now let's kind of collect these two ideas together. And we've got 1/2 base times height for the area of the triangle, and the height can be written as a times the sine of C. Well, look how easy this is going to be for me to substitute a sine C in place of h in that ordinary triangle area formula. And what I get is this. The area is 1/2 times b times a times the sine of C. So that looks like the formula right there. Now I've used those two sides, A and B, and angle C, but it doesn't really matter. I could have solved it for other, constructed it for other two sides of the triangle and other angles. So here's a generic way of describing this side angle side area formula. You could say that the area of any triangle is 1/2 of the product of any two sides times the sine of the angle that's in between those two sides, or we call that the included angle. So that's the formula. It's a very simple formula to use, and what's nice about it is that you don't have to worry about whether the angle is expressed in degrees or radians. It doesn't matter, because you're taking the sine of that. As long as if you're using a calculator, as long as your calculator is in the correct mode, you will not have any problems with this. So no degree conversions are necessary to use this formula. So let's look at a really quick example here. There's a little triangle, and one side's 13, the other side's 15, and the angle in between those two sides is 24 degrees. You know, it's just so simple. You just multiply all that stuff together. 1/2 times 13 times 15 times the sine of 24 degrees. And that's your answer there. Your calculator will give you a number, something like that, 39.7 square units. Piece of cake. Let's look at an example that is a little bit more challenging and doesn't really have as its goal, a final goal, using this side angle side area formula, but uses that formula to achieve something else. Okay, so I'll show you this, and you'll see a couple of problems like this in the homework too. So here's a circle, and what I'm interested in this circle is the area of that shaded region there that's in between the chord and the circle itself. It's actually called a segment of a circle. So in this circle I have constructed the central angle subtending that arc there is 2 pi over 3, and the radius of the circle is 12. Okay, so what I'm going to do first is find the area of the sector of that circle, and we've looked at that formula already. It's 1/2 r squared times theta. And remember, here it is very important that theta be in radians. It does not work if you use degrees. So putting those numbers in for r and for theta gives me that. I can kind of work that out. 72, 2 pi thirds, blah, 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 and I get 48 pi square units for the area of the sector. Okay, and if you're thinking ahead of me a little bit here, you're thinking, well, okay, if I take that sector area and I subtract the area of that triangle, then that's going to leave me with the shaded area that I'm looking for. All right, so let's figure out the area of the triangle using the side angle side area formula. Both sides are the same, right? They're both radii of the circle. And the angle in radians there, 2 pi thirds, as I said, it doesn't matter what mode, what form that angle is expressed in. Radians works just as well as degrees. So the sine of 2 pi thirds, I can work that out. I can do all the other calculations there. And it's easy. 36 root 3 equals the area of that triangle. Okay, so I've figured out the area of the sector. I got the area of the triangle in between. Let's kind of take just a little moment to strategize and make sure that we're doing the right thing. I can tell quite simply then that the area of that shaded region there, that segment of the circle, is going to be the sector minus the triangle. Okay, so there's my sector, I figured that out, and there's my triangle, I've already figured that out, and so all I got to do is subtract. That's going to give me the shaded area. 48 pi minus 36 root 3 gives me 88.4, more or less, square units for that shaded segment of that circle. Okay, well that's it. Hope you had a good time watching that. Hope it's clear, and I'll see you soon. Be well.